we present Voxgraph, a framework for globally consistent volumetric mapping using signed distance function submaps. Globally consistent dense maps are important for robot navigation. In GPS-denied environments, robots typically estimate their motion incrementally. This leads to position and map errors that accumulate over time. The map on the left is constructed using perfect pose estimates, while on the right we simulate accumulated error resulting in a distorted map. We present a mapping framework which produces globally consistent dense maps even on small robots. The framework constructs a set of signed distance function submaps, each shown in a different color. Our proposal maintains consistency through geometric alignment of the submaps. We now show the merged map. The red, green, and blue spheres show the drifting input, Voxgraph's estimate, and the ground truth robot pose. To perform alignment efficiently, we generate correspondence-free constraints by leveraging the underlying SDF representation. We demonstrate the system in various environments. We map a large search and rescue training area using a 3D LiDAR. We also map an industrial space using a depth camera. In this dataset, we use external loop closures to correct large alignment errors. Thank you for listening. Please visit our open source project on GitHub.